Hello, this is Mrs. Taylor, and I'm going to talk to you about the properties of limits. So to start with, we're going to look at some basic limits. It's page 59 out of your textbook. This theorem states, let b and c be real numbers and let n be a positive integer. So that's a non-decimal number that's positive. And the three basic limits we have here is the limit as x approaches c of b equals b. So c represents an real number, b and b obviously represent real numbers. So this is saying if you just have a real number here, it doesn't really matter what x is approaching, your limit will be equal to that same real number. Number two, the limit as x approaches c of x equals c. C, remember, is a real number, and x is just some variable. So all this is saying is if you just have x here, as x approaches whatever that c value is, the limit will equal that same value. And the last one, the limit as x approaches c of x to the n equals c to the n. Remember, n is a positive integer, c is some real number. So all this is saying is that you would replace x with c, and then you'd raise it to whatever power n represented. And so just to apply these three basic limits, these three basic properties, A would be like number 1, where we just have a constant. So our limit would be equal to whatever that constant is. B, limit as x approaches negative 4 of x. Again, this is like number 2. So we would just plug the c value in for x, and that would be what our limit would be equal to. And then c, x approaches 2, the limit as x approaches 2 of x squared would be like number 3, where we would replace the x with the c value. That would be 2, and it would be 2 squared, which would equal 4. So those are some basic limits, some basic properties. Our properties of limits as far as being able to add, subtract, multiply, divide, things like that are listed here. Again, we're letting b and c be real numbers, n a positive integer, and f and g be functions with the following limits. So let's say they told you that the limit of this function equals L and the limit of this function equals K. And so what we're going to do is we're going to use L and K to represent these properties. The first one is a scalar multiple. So if we take our function f of x and we multiply it by some real number, a scalar, what this property is stating is that I can find the limit of f of x, represented by L, and then just multiply it by that scalar. So I can work with them one at a time. Sum or difference, if I have two functions that are being added or subtracted, I can find the limit of each function separately and then add those two limits. The product property, if I'm multiplying two functions, I can find the limits of those functions separately and multiply those limits. Quotient, same thing. If it's being divided, a function divided by another, I can find the limit of each function and then divide it. That is only under the condition where the limit of the denominator function does not equal 0, because then it would be undefined. And we will look at cases where it does equal 0. Not today, though. And then lastly, if we have some function raised to a power, then I can find the limit of that inner function and raise it to that power. So these just make limits a lot easier to evaluate. So what the exercises will look like using these properties is instead of giving you functions that you can look at graphs of, you'll be given the limits of those functions. So you won't know what f of x is representing, but you'll know the limit of that function at some c value. So here, if the limit as x approaches c of f of x equals 2, and the limit as x approaches c of g of x equals 3, then I want you to evaluate each of the following. So A represents our scalar multiplication, scalar multiple scenario, where we can find the limit of g of x and then multiply that limit by 5. So the limit of g of x is 3, so I can do 5 times 3 and get the limit, which would be 15. B This is your addition, where you can find the limit of each function separately and then add them. So that would be the limit of f of x, which is 2, plus the limit of g of x, which is 3. This would equal 5. This is multiplication, so you'd multiply the two limits, 2 times 3, which would be 6. And then your quotient property, where you just divide the limits of the two functions, so 2 over 3. And fractions are better because they're more exact, so we're just going to leave that as a fraction instead of dividing it out. Some other properties that are going to come in handy is the radical property. So we've seen rationals, which are quotients, polynomials, that's where you had x or x squared. So here, the radicals, all this is saying is the limit as x approaches c of the nth root of x is equal to the nth root of c. So you just take whatever x is approaching, substitute that in for x, and evaluate. The limits of trig functions, pretty straightforward. If you're taking the limit of a trig function, you just substitute the c value in for x and then evaluate. So it's pretty straightforward. This would be equal to the limit of tangent of, this limit would be equal to tangent of 0. This would be equal to pi times cosine of pi. Forgive the sloppy writing, I'm writing with the mouse. And then lastly, the limit as x approaches 0 of sine squared of x would just be sine squared of 0. And just to give you a heads up, you will have to be able to evaluate these trig functions from memory. So go ahead and practice now memorizing what they are. Let's see. So that covers the basic properties of limits. The big idea here is this list of the 5 properties where you can find the limits of the functions separately and then bring them together for whatever the operation is. So whether it's adding, subtracting, dividing, multiplying, raising to a power, or multiplying by a scalar.